everyone, welcome to APS Deep Academy and this is your mentor Swati Joshi. In this class, we will study practical PN junction diodes. Now, what a practical term means here? Practical means the real one. Diodes which are realistic in nature, which we are using in our electronic devices. So, in last class, we studied the ideal diode, which was the condition where we only use these conditions for taking the parameters and making the assumptions. But here the practical diodes, we use practical diodes in our electronic circuitry in real time. Now, this is the symbol of diode. Diode is a two-terminal device and this is considered as positive side or anode. This side is considered as negative side or cathode. In diode, current flow only in one direction due to the forward biasing of the diode and the current is forward current. Now let us quickly review what is happening in a PN junction. In P side, holes are in majority, N side, electrons are in majority. Due to the process of diffusion, the hole try to penetrate this layer and jump into the N side and these electrons try to penetrate the layer and jump into the P side. What happened in between? They both recombine with each other and the charge are neutral because the negative charge fully occupy the positive charge. It means the negative charge fully depleted the positive charge. Depletion means the absorb power. So electron fully absorb the whole here. So this is also called the depletion layer. Now this depletion layer acts as a barrier here. What happened? Due to the formation of depletion layer, here the negative charges are gone, so a layer of positive charge will increase, and in here positive charge are gone, so a layer of negative charge will increase. What happened? From positive to negative, electric field will generate, and this electric field will create a potential barrier or a voltage difference. This barrier is considered as knee voltage or a barrier voltage. This knee voltage is the operating voltage for particular diodes. After this knee voltage, the conduction will start. But before this knee voltage, the diode acts as a blocking bias. Now let us consider the forward bias condition and the VI characteristics of practical PN junction diodes. In forward biasing, we connect positive side of the battery to the positive terminal of diode and negative side of the battery to the negative terminal of the diode. And this is the resistor which we consider as current limiting resistor. Resistors are used so that the excess flow of current inside the circuit will consume with this resistor and the output will not disturb. So this is the practical diagram of a forward bias condition. Now what happened? Let us study it in detail. If this is a PN junction and I am connecting it in forward bias, this positive and this positive charge, they both charge are repelling each other, and this negative and this negative charge, they both are repelling each other. So they are trying to move into this direction. So the layer which we studied, considered as depletion layer, will cross the potential barrier, will cross. If this voltage increase, so the electron and hole try to penetrate this layer and they cross if they cross the knee voltage, then the current will start flowing in a particular direction which is considered as IF. Before the knee voltage, the current is negligible, and after the knee voltage, the current is increasing exponentially. Now here, two things we have to consider. One is the case of thermal voltage, one is the case of the applied voltage. Due to the applied voltage, we already see that this depletion region is making thinner and the electron and hole try to move towards the layer and take part in conduction and start flowing the current IF. But due to the presence of temperature also inside this depletion layer, few electrons or holes recombine. When the temperature increase, the electron and hole recombine with each other and start flowing a current, which is very negligible in nature, but we consider it in our VI characteristics. So this is our I naught, or sometime it is called IS or IRS. So this is nothing but a reverse saturation current, which is due to the effect of temperature in forward biasing. Now let us deeply understand the VI characteristics of forward biasing. This is the voltage in x-axis and current in milliampere in y-axis. Okay, this is the 0 volt and this we will consider as 1 volt. Now what happened till 0.7 volt in the case of silicon, the forward current is not flowing. Why so? Because it has to attain the knee voltage or the cut-in voltage. So this is the knee voltage or the cut-in voltage or the barrier voltage. When the diode achieves this, so it starts flowing in exponentially, and the increase is the current increase in milliampere, and this is considered as forward current or IF. Okay, so this is the basic VI characteristics of a forward bias practical PN junction diode. Now, with the help of the formula, we will discuss it in detail. Formula of forward current IF is I naught, or saturation current, e to the power Vt upon utility factor Vt. So, this is the saturation current which I already discussed due to the minority charge carrier or due to the effect of temperature inside the junction. And this is the sign of exponential. We know that the current is increasing, the forward current is increasing exponentially. So, we will take the exponential term of Vd upon Vt with a factor of utility factor of this. So, this symbol is considered as utility factor. This utility factor is 1 for silicon and 2 for germanium. Now, this Vd is our forward voltage which we are giving, and Vt is our thermal voltage which we consider at room temperature. Okay. Now, this is the basic formula of what a forward current is. Let me write it in again with some clarity for you. If is nothing but I naught, or the saturation current, which we already know that saturation current is nothing but due to the effect of temperature or the minority charge carrier is there, e to the power, which is used for exponential, as we know that forward current increase exponential, e to the power Vd. Vd is our forward voltage which we apply upon efficiency factor or a utility factor Vt. Vt is our thermal voltage, and this is utility factor is 1 for silicon and 2 for germanium. So, this is the equation of forward current in practical PN junction diodes. Okay, now we will quickly discuss the reverse bias condition. Now, what happened in reverse bias condition? We connect the negative terminal of the battery to the anode and positive terminal of the battery to the cathode. So, this is our reverse bias. In reverse bias, this positive and negative charge attract each other, so the charges flow in this direction. Similarly, here also the charges attract each other, charges flow in this direction. So the depletion region of this PN junction, will increase or will become wide. And if this becomes wide, then it need very high voltage to rupture or break the covalent bond inside this layer and start flowing conduction. So this reverse bias condition is also considered as blocking bias because it is blocking the current. Okay, blocking bias. It is blocking the current to flowing. Till a particular very high voltage level, when it attain a very high voltage level, then the covalent bond rupture inside the layer, and we consider this as breakdown of the diode, which we will discuss in another class. But today we will discuss the VI characteristics of reverse bias also. So this is the blocking bias. And now with the help of a diagram, I will show you the forward and reverse bias characteristics on a single page. Okay. Now these are the VI characteristic of forward and reverse bias of practical diode. See here what is happening. Till it attaining a knee voltage, which is also considered as cut-in voltage, the current is negligible or zero. But after that, the current is increasing exponentially. So this is our forward current. Okay, and this is our forward voltage here. And this is the forward current in milliampere. And one thing you have to note here, this is the reverse current is in microampere. So if the forward current is in milliampere, the reverse current which is in microampere is 10 to the power minus 6, which means very low, 10 to the power minus 6, very low current possessed in reverse bias. So till it attain a particular breakdown voltage, the current is negligible or considered as very small, or similarly to zero, or in, it is, if this is in 0.5, like this is in 0.1 microampere. So it is very negligible. 0.1 microampere, negligible current is flowing till it attain a breakdown voltage. And after it attaining a breakdown voltage, the sharp shooting current is flowing. So this is considered as the breakdown current or the reverse saturation current. So this we will discuss in our next class or another class, that what are the mechanism or how the practical diode work in reverse bias condition. Okay, so this is the basic of VI characteristics of practical diode here. Today we will study it in detail. Now this is the end of the lecture for today. Thank you so much.